Suppose you're testing a frontier model for security research, and the answer changes. The model didn't get worse, and your prompt didn't change. Some internal policy routed part of the request through a different path and didn't tell you. On Thursday, June 11th, Anthropic's Claude developer account said Fable 5 will now make that kind of fallback visible. Flagged frontier large language model development requests will show that they are using Opus 4.8 instead.
That's a much smaller sentence than the trust problem behind it. A visible fallback means the developer can separate two cases. Fable 5 answered this, or a safeguard moved the request to Opus 4.8. Before that, the user had to infer the routing from behavior, while behavior was the thing under evaluation.
Right. The Verge reported today that Anthropic apologized after hidden safeguards around Fable produced backlash, especially from people doing cybersecurity and model behavior work. Simon Willison's post on the change treated the visibility update as the key developer-facing repair, and I think that's the correct scale for it. This doesn't settle the policy question. It does change whether the system tells you when policy has intervened.
And that distinction matters more for researchers than for casual chat. If I'm asking a model to summarize an email, maybe I can tolerate some invisible routing if the output is fine. If I'm checking whether a model can reason about exploit construction, biosecurity-relevant protocols, or frontier model development assistance, the root is part of the result. A hidden intervention contaminates the measurement.
There is a generous version of Anthropic's problem here. They are trying to ship a very capable model while not handing over every capability at once to every user. That isn't a fake problem. Labs are going to have policy layers, routing layers, refusal layers, and probably model-specific fallback behavior for a long time. The repair can't be no safeguards. The repair has to include, tell me what system I am talking to when a safeguard changes the answer.
Yes, because the developer contract isn't only give me the best answer, it's also give me enough surface area to debug the system. A model product that silently swaps engines in the middle of a sensitive evaluation is asking the user to trust a black box around the black box. That's a lot to ask from the exact users most likely to notice the handoff.
And the apology matters because yesterday's conversation around Fable was already tangled up in access, retention terms, and research restrictions. I don't want to replay that whole story. The new fact is more concrete. Anthropic is making the safeguard visible in the product. The open question is whether that becomes the general norm for frontier systems, because model identity, policy identity, and tool identity are all becoming parts of the answer.
The norm I would want is pretty simple to state and annoying to implement. If a policy layer changes the model, the tools, the context, or the allowed action set, the user-facing trace should say so. Maybe it is a banner, metadata in the API response, or a run log, but the event needs to exist somewhere a serious user can inspect.
The Fable update is the most visible example, but the same governance problem shows up elsewhere. Data centers are meeting national policy. Agents are meeting runtime authority. AI search summaries are meeting legal exposure. Robotics papers are asking what happens when the model has to act on sensor time rather than demo time.
So the episode is less, one company changed one safeguard, and more, every layer around these systems is becoming part of the system. The policy layer affects the answer. The power contract affects the cost. The identity boundary, the timing loop, and the evidence trail all change what the system can safely do. If you build with AI now, you aren't only choosing a model, you're inheriting the machinery around it.
Axios reported today on a new U.S. congressional bill aimed at AI data centers. The article summary doesn't give us the full legislative text, so I won't pretend we have it. But the fact of the bill matters because it moves the data center fight out of pure local permitting and into national policy.
And that follows the week we've been having. Monday had drought and water. Wednesday had capacity financing and regional deals. Today's update is that elected officials are starting to treat data centers as a national infrastructure category that needs explicit rules, not as ordinary commercial buildings that happen to use a lot of power.
The Guardian's Australia piece points the same direction from a different angle. AI data centers are being discussed as an economic growth story and as a resource control problem for the Labour government. Al Jazeera's explainer keeps the physical side in view: heat, power, water, and location. That mix is the point. A data center is a policy object because it touches all four.
the physicality is easy to lose when the conversation is all tokens and GPUs. A model call feels weightless from the browser, but the build-out behind it depends on power equipment, cooling systems, land agreements, and contracts. Nearby communities may get the jobs and tax revenue. They may also get the noise, heat, and power constraint.
Michiel Backer's post today as the European anxiety. Compute imbalance is becoming a geopolitical concern. Again, I would keep that at the level of a signal from one post rather than a full argument, but it fits the broader picture. Countries and regions don't only want AI applications, they want some claim on the capacity underneath them.
Which is why a national bill changes the conversation for builders too. If you're a lab, a cloud provider, or even a company buying reserved capacity, your roadmap starts to depend on permitting timelines, grid interconnects, environmental review, and political tolerance. That isn't distant policy theater. It can change inference costs, capacity availability, and the schedule for opening new regions.
I would keep the altitude modest here. This isn't the day data centers became political. They already were. The fresh piece is that the politics are becoming more legible at the national level. The AI industry is getting pulled into a public accounting for heat, electricity, water, and local bargaining power.
There is also a product implication. When a model vendor says it will serve more users, lower latency, or cheaper inference, the capacity plan is part of that claim. If the underlying build-out hits policy friction, the product promise changes. You can't separate the launch blog from the power queue forever.
And you can hear the connection back to Fable without forcing it too hard. Visibility is the recurring demand. In the model case, show the fallback. In the data center case, show the resource costs and the local terms. The public doesn't need a mystical account of compute. It needs enough information to argue about the trade-offs in ordinary, institutional language.
That sounds plain, but it's a hard standard. It means the industry has to translate accelerate accounts and training runs into power permits and grid upgrades. It also has to explain emissions accounting and community benefits. The people making those decisions won't all be AI specialists, and they still get a vote.
MIT Technology Review reported today that Google DeepMind is worried about what happens when millions of agents start interacting. That's the headline version. The practical version is sharper. Once agents can act on your behalf, their safety depends on runtime authority as much as model output.
Enterprises can't handwave runtime authority. An agent with no access is a chatbot. An agent with calendar access or repository access is an actor inside a system. Add customer data, procurement rights, or payment authority, and the governance question changes fast.
The agenda pairs that reporting with an RICIF paper on a 5-plane runtime architecture for governing production AI agents, plus another paper about non-compliance and refusal behavior. I won't judge their architectures in detail from summaries alone, but the pairing is useful. The field is trying to move from make the model safer toward build systems where authority can be assigned, limited, observed, and revoked.
That is the enterprise problem in one sentence. Access was the exciting part. Revocation decides whether the system survives contact with auditors, incidents, and angry customers. If an agent books the wrong thing or approves the wrong refund, someone needs to know which policy let it happen.
Forbes has 2 pieces today that are more commentary than primary evidence, so I would use them as color rather than foundation. One argues that agents are becoming employees and should be governed more like employees. The other says the most dangerous AI in a company is the one nobody owns. I don't love the employee metaphor when it becomes too literal, but the ownership point is hard to dodge.
The employee metaphor breaks if it makes us pretend the agent has judgment, duty, or accountability the way a person does. But it helps if it makes a company ask basic operational questions. Who provisioned this account? Who approved its permissions? Who reviews its actions? Who can suspend it today without breaking 3 departments?
And multi-agent interaction makes that messier. A single agent can be reviewed as one workflow. Millions of agents interacting means agents can create pressure on each other, price discovery, spam, negotiation loops, automated customer support deadlocks, procurement bots chasing each other's offers, and probably a lot of behavior that looks silly until someone attaches money to it.
The product surface has to include the breaks, not theatrical breaks, actual controls. The system needs scoped credentials and action receipts. It needs policy checks before irreversible steps. It needs sandboxed dry runs and logs that explain what the agent believed it was allowed to do. The refusal can't live only inside the model weights, because the model doesn't know every local rule your company cares about.
That's why I keep coming back to traces. A trace isn't glamorous, but if you can't reconstruct the path from instruction to permission to tool call to side effect, you don't govern an agent. You just hope the demo behavior survives production traffic.
And if there are many agents, the trace also has to show interaction. Who influenced the decision? Which agent supplied the claim? Which external source got pulled in? Which human approved the step? Without that, post-incident review becomes folklore. People sit in a room and argue from memory while the system keeps running.
The continuity with this week's earlier agent security stories is that we can stop pretending the model is the whole unit of deployment. The deployed unit includes the model and its memory. It includes tools, policy, credentials, scheduling, logs, and human review. Today's governance pieces are about naming that larger object and giving teams somewhere to attach rules.
And that larger object is what users will blame. They won't say, the language model made an unauthorized procurement decision after a permissions misconfiguration in a tool adapter. They'll say, the AI bought the wrong thing. Internally, you need the details because externally, the system will be treated as one product.
Indian Express has a single source item today on a court ruling involving Google's AI overviews, and the agenda's caution is the correct one. Don't overbuild the legal claim without the underlying ruling. So let's keep this brief. The product point is that AI-generated search summaries are now carrying enough legal risk that the summary box itself becomes part of the liability surface.
That's a good short item because the engineering question is concrete. A search engine used to point to pages and rank them. AI overviews synthesize an answer. Once the product writes the answer, you get new questions about attribution, accuracy, reliance, defamation, medical advice, financial advice, and whether the user had a meaningful path back to the original source.
And this is another place where visibility matters. If the summary is generated, what sources did it use? Did it quote, paraphrase, or infer? Did it answer from a page that changed? Did it collapse conflicting pages into one confident sentence? For a search product team, those questions become UI work. They also become ranking, logging, and evaluation work.
It also changes incentives for publishers. If the answer appears above the links, and the answer is wrong, the publisher may be harmed by an error it didn't write. If the answer is right, the publisher may still lose traffic from work it did write. Those are different complaints, but the product design has to make both legible.
I wouldn't take one article and declare a global legal turn, but I would treat it as another sign that AI answer products are leaving the novelty phase. Courts, publishers, regulators, and users are starting to ask who owns the synthesized sentence. Search teams are going to need better provenance and better correction paths. Answer quality alone won't settle the dispute.
And provenance has to be designed for normal users, not only for expert auditors. A tiny source chip that nobody opens may satisfy a UI checklist, but still fail the person trying to understand why the answer said what it said. The hard product work is making source context visible without turning every query into a legal appendix.
The robotics slice of today's archive batch is unusually coherent, even if I would still treat the claims as paper claims. One paper announces embodied R1.5 as an open embodied foundation model. Another attacks the synchronous clock assumption in vision language action systems by moving toward asynchronous sensor rate processing. A third, uni-intervene, is about reducing human intervention cost in real-world reinforcement learning.
That trio is interesting because it sounds less like, look at the robot demo, and more like, how do we make physical control behave under deployment constraints? Open weights and datasets are one axis. Timing is another. Human intervention is a third. Those are the places where a robot leaves the video and starts becoming an operations problem.
The timing paper is the one that caught me from the summary. A lot of vision language action work, as presented to non-specialists, can feel like the model observes, thinks, and acts in neat steps. Physical systems don't respect that neatness. Sensors update at different rates. Motors have latency. The world changes while the policy is still deciding.
Exactly. If your camera, tactile sensor, and controller all have to wait for one synchronized reasoning tick, you may be throwing away information or reacting late. Asynchronized processing isn't just an implementation preference. It can decide whether the system catches a slip, adjusts grip, or drives past the moment when correction was possible.
And uni-intervene points at the labor side. Real-world reinforcement learning often needs people to reset tasks, stop unsafe behavior, correct the policy, or supply interventions. If a framework reduces that burden, the economic meaning isn't only better learning, it means fewer humans babysitting the training loop per useful hour of robot practice.
This is where robotics starts to echo the agent governance segment. The robot needs authority too, but authority in physical space includes momentum, contact, breakage, and human proximity. A software agent can send the wrong email, a robot can drop the glass, hit the fixture, or learn a shortcut that works in the lab and fails on a slightly different floor.
The open-embodied model claim should be handled with restraint. The abstract positions it as a state-of-the-art open-source embodied foundation model with open weights and datasets. That's meaningful if the release holds up, but the important builder question is still reproducibility. Can other labs run it, compare it, and find the boundary conditions?
And the boundary conditions are often where the actual product lives. Does it work with a different gripper, a worse camera, a slower network, a cluttered room, a user who stands in the wrong place? The benchmark score may get you attention, but deployment is where timing, intervention, and recovery decide whether the system is useful.
So this is a mention, not the lead, but it belongs in the episode because it broadens the same question. In software agents, we ask who authorized the action. In robotics, we also ask when the system knew enough to act, who can interrupt it, and what evidence remains after the motion happens.
The evidence after motion is a subtle one. Logs are easier when the action is a text response. Once a system moves through the world, you need sensor history, policy state, intervention records, and probably video. Otherwise, you can't tell whether the error came from perception, planning, actuation, or a human rescue that never got recorded.
The last cluster is a compressed research agent beat. Several RxIV papers today describe systems for autonomous research. Arbor uses hypothesis tree refinement. Scicon Bench and Scicon Harness evaluate scientific conclusion synthesis. Other work in the group focuses on evidence management and metric design. The agenda is right to group these by problem instead of paper title.
Because otherwise we end up reading a catalog. The shared problem is that research agents can produce plausible claims faster than humans can inspect them. So the engineering work moves to search discipline, evidence control, disaggregated metrics, and keeping conclusions attached to the observations that support them.
The weaker claim would be that the agent discovers truth while we clap. The more grounded claim is modest. Can the system organize hypotheses and searches, connect experiments to evidence, and let a human researcher audit the path before deciding what deserves belief?
And the metric warning matters. Aggregate scores can hide the step that failed. A research agent might retrieve well and summarize well, then overstate the conclusion. Or it might generate good hypotheses and choose weak evidence because the search loop rewarded novelty over support. You need to measure the parts separately.
The last research agent point loops back to the first item. Hidden routing damaged trust in Fable because users couldn't tell which system they were evaluating. Research agents face the same class of problem inside the work. If you can't see how the claim was formed, you can't tell whether the conclusion deserves confidence.
And the answer isn't to make every user read every trace. The answer is to make the trace exist, make it queryable, and make the product plain about when the path changed. A researcher may need the full audit trail. A normal user may need one sentence and a source link. Both depend on the system recording the event.
A good test for the next version of these systems is whether the rule that changed the behavior leaves a mark. A model fallback and a permission check both need a record. So do a policy refusal, a source choice, a robot intervention, and a research conclusion. A serious user should be able to ask what happened and get an answer.
Thursday's stories don't combine into one giant verdict. They're smaller and more practical than that. Anthropic made a fallback visible, while data center politics became more explicit. Agent governance moved toward runtime controls, search summaries picked up legal pressure, robotics papers pushed timing and intervention forward, and research agents kept coming back to evidence.
That is the developer contract I would want from the day. Not perfect models, and not frictionless infrastructure, just systems that admit when the path changed, because the path is now part of the product. Lenar Kess.